Okay, we're going to finish up with a few types of equations and inequalities to finish off our review topics here for the first test. So in terms of equations, next up we have absolute value equations. On these, it's really important that on the first step, if necessary, you isolate the absolute value. You always want to get it down to the absolute value expression is equal to a number. So on this one, before I do anything else, I need to add 7 to both sides. And I get the absolute value of 2x plus 1 is equal to 5. I do negative 2 plus 7 there. And then at this point, if I happen to get a negative on the other side, and you might in a homework problem, then there's no solution. Absolute value can never be negative, so you would have no answer. But if you get a positive number, or if you get 0, you're going to wind up with one answer. You just set the inside equal to 0 and solve. But if you get a positive number, it could be that the absolute value of that is canceling a negative sign. So it could be that 2x plus 1 is 5 or negative 5. So 2x plus 1 could be plus or minus 5. We get two answers to this when we solve. So the general approach on an absolute value equation is isolate the absolute value and then set it equal to the positive and negative of that number as long as it's a positive number. If it's negative, there's no solution. And so I get 2x plus 1 equals 5, which I subtract 1, divide by 2, and we get x equals 2. But also we could have 2x plus 1 equals negative 5, and then the absolute value of that would be 5 and solve the equation. And we solve that when we get x equals negative 3. So typically absolute value equations have two answers. If you wind up with absolute value equals 0, you would only get one answer, and if you have a negative number over there, you get no solution. But if you have any positive real number over here, you're going to wind up with two answers. Then we also did quadratic and form equations. Looks like my animation's messed up. I forgot to include that. One of our answers is going to be x equals 1/4, but we'll see that here in a second. So on this, these are similar to quadratics, where instead of ax squared plus bx plus c, we have different powers of x. So we have a constant, we have a power of x, and the square of that. So I have here, you want to note, it really is quadratic in form, because if we take the part in the middle here, x to the negative 1, and we square that, by the rule, we would multiply and get x to the negative 2 for the power. So I can solve this by quadratic methods. I could use quadratic formula if I wanted and find my answers for x to the negative 1, but most of these actually wind up factoring on these types of problems that they give us in the book here. So I look at the numbers. I need to multiply and get negative 12, add to get negative 1, negative 4 and 3 will accomplish that. And I have to use x to the negative 1s so that that's what I get in the middle, and then when I square it, I get x to the negative 2. So I can factor that expression into x to the negative 1 minus 4 times x to the negative 1 plus 3 equals 0. And then I set each of those equal to 0 and solve, and I get x to the negative 1 equals 4. X to the negative 1 minus 4 equals 0. Add 4 to both sides. You can think of that like we did the rational equations. I can take my negative 1. If I flip it, I still get negative 1, but I raise both sides to the negative 1 and get x equals 4 to the negative 1, which by definition is 1/4. Or x to the negative 1 is 1 over x. If 1 over x equals 4, I flip both sides and get x equals 1/4. We also have x to the negative 1 plus 3 equals 0, or x to the negative 1 equals negative 3. Flip both sides, we got x equals negative 1/3. Okay. So the general approach there, it's quadratic in form. Once I verify that, I can factor, but I do it with the term in the middle there, in this case x to the negative 1. I solve for that, and in this case I get x to the negative 1 equals 4, x to the negative 1 equals negative 3. Then I have to do something with the powers to solve the problem. Here I raise both sides to the negative 1, which means do the reciprocal, and we get 1/4 and negative 1/3. And then we did inequalities. Okay, so our next topic is linear and compound inequalities, compound linear inequalities. Compound means you have more than one you have to solve simultaneously, and we will look at that in a second. But first, we're going to do number 11 here and solve this linear inequality. And your answer usually winds up being an entire interval or combinations of intervals, and we'll express our answer in interval notation. But on this one, we're going to solve it very similar to how we would solve if it was an equal sign in the middle. We're going to isolate x on one side, but if we multiply or divide by a negative, we have to flip the inequality sign, because that's how it works on the number line when you cross over 0 when you look at less than greater than. So first I'm going to do a little simplification. We can distribute the negative 5 and get negative 5x plus 5 plus 3. And then I can do 3x minus 4x on the other side and get negative x minus 4. And then I have like terms there. 5 plus 3 is 8. So we have negative 5x plus 8 is greater than negative x minus 4 if we completely simplify both sides. And then I need to move all the x's to one side, all the numbers to one side. I subtracted 8 from both sides and got negative 5x is greater than negative x minus 12. And then add x to both sides. We get negative 4x is greater than negative 12. Divide both sides by -4, which is negative, so it flips the inequality sign, and I get x is less than -12 over -4, or +3 when the negatives cancel. I always, when I'm teaching the intervals, I like to draw a picture of the number line. Sometimes they'll ask you to draw this picture, but it's x less than 3, so it's from 3 off to -infinity. You always write smallest to biggest when we write the interval in a minute, but we have an open circle at 3 or a parentheses at 3. Sometimes the books will use parentheses and brackets just like the intervals. But we don't include 3 because 3 is not less than 3, but anything less than 3 we would include, so we got an arrow going off toward -infinity. Now the interval is a shorthand of the number line without drawing the number line, and you always have to go left to right, smallest to biggest. So it's -infinity to 3. We always put a parentheses on -infinity because there is no endpoint. A bracket means you have an endpoint that's included, and we don't include 3, so we have a parentheses there. Okay. Don't write, a lot of people write things like 3 to -infinity. That's the empty set. There's no numbers that are bigger than 3 and less than -infinity. It's always smallest to biggest because it's literally a shorthand notation of what we see on the number line there. It's from -infinity to 3 in that order, and parentheses on both ends because no endpoint on the infinity side and the other endpoint is not included. All right, compound inequalities. Those you have either and or types of problems. Here on 29's an and problem. It could be split apart. I have to split it to solve it, but we have 3x plus 1 is greater than 2x minus 5, and 2x minus 5 is greater than x minus 7. So we can split that and write it as two separate inequalities. We have 3x plus 1 is greater than 2x minus 5, and 2x minus 5 is greater than x minus 7. Solve each of those separately. Okay, these are linear again, so I just isolate x. So if I subtract 1, I get 3x is greater than 2x minus 6. Subtract 2x. Looks like I messed up my animation there again, but subtract 2x and we get x is greater than -6. Solve the other side. You add 5 to both sides. You get 2x is greater than x minus 2. And then subtract x from both sides. X is greater than -2. So we have here, and we have to figure out how to get this as an interval for our solution, but we have x is greater than -6 and x is greater than -2. If you look at those, they overlap each other. I've put them both on the number line. We have x is greater than -6 and x is greater than -2. For an and, it has to be where they overlap, the part that satisfies both of them, and that's just going to be x is greater than -2. If it's greater than -2, it's greater than -6. I can't include numbers like -4 because those don't satisfy the x is greater than -2. So we could shade them both and see where they overlap. Where they overlap would be the answer. So from -2 to infinity. Again, parentheses on -2 because that's not part of our answer. -2 is not greater than -2. So the values where it's greater than -6 and greater than -2 are where it's greater than -2. With an OR problem, we find both solutions and then combine them both together. It's an OR instead of an AND. We take what's called the union instead of the intersection. The AND, we take the intersection where both are satisfied. For the OR, we just need at least one to be satisfied. But we solve the two. So we have 2x minus 5 is less than -11, so I solve that first. So I add 5 to both sides and get 2x is less than -6. Divide by 2, get x is less than -3. 2 is positive, so it didn't flip the sign. Remember, if we multiply or divide by a negative, we flip the sign, but otherwise we keep it. So we got x is less than -3. Or we have 5x plus 1 greater than or equal to 6. Subtract 1, we have 5x greater than or equal to 5. Divide and get x is greater than or equal to 1. So this is two separate pieces when you look at it. We have x is less than -3 on the left side of the number line, or x is greater than or equal to 1. In terms of the endpoints, we don't include the -3, we do include the 1. I've used open and closed circles on my pictures there. If it was an AND, it would be no solution. They don't overlap. But the OR, if it's in either set, it's part of our solution, so it's both intervals. -infinity to -3, union 1 to infinity. I have a parentheses on -3 because that side just had a less than. 3 is not less than -3. But 1 is greater than or equal to 1, so I include the 1 with a bracket. Okay. And then finally, our last topic, solve absolute value inequalities. These turn into compound inequalities. The greater than becomes an OR, the less than becomes an AND. But on these, you also want to make sure that you isolate the absolute value first, just like on equations, and then start working on the solution. So here's a problem. We don't have to do anything to isolate it, but we've got absolute values greater than or equal to 5. If you look at the number line and you think about that, that'll work whenever the values are bigger than 5 or less than -5, when they're more than 5 away from 0 on the number line. So that's an OR problem. We'd get a solution if it's either bigger than 5 or less than negative 5. And I solve each of those, just subtract 3 from both sides on each of those, and you get x is greater than or equal to 2, or x is less than or equal to negative 8. Two separate pieces. These typically there, you look, you've got two separate pieces. You're going to have brackets on both with the intervals. We've got negative infinity up to negative 8 for the x is less than or equal to negative 8. For or, you could use a comma if you wanted, but I've used the union symbol, which means or there. And then we have 2 to infinity, so bracket 2 off to infinity. Okay. So if you have absolute values greater than a positive number, you split it into the two pieces. It could be bigger than the positive value, less than the negative value. Solve those, and you get your two pieces, your two intervals that you put together there. For and, it has to be trapped between the positive and negative, but you need to isolate first. When I looked at the homework, they were actually all isolated already, and I wanted to make sure we did an example where they weren't. So we have absolute value of x minus 2 minus 1 is less than 6. So the first thing I would do is add 1 to both sides and get the absolute value of x minus 2 is less than 7. Now, this means the absolute value is less than 7, that our values are no more than 7 away from 0 on the number line. It's between negative 7 and 7. It's exactly the opposite of the greater than type of problem. That's an and problem. You can split it. This one, since you just have numbers on the two sides, you can actually solve it all at one time if you want. We have negative 7 is less than x minus 2 is less than 7. So if the absolute value of x minus 2 is anywhere between negative 7 and 7, we'd get a solution here. I can add 2 to all three sides and get negative 5 is less than x is less than 9. So that shows me x has to be between negative 5 and 9. That's what the picture looks like. Those should actually be open circles on those. And then you have negative 5 to 9, which is parentheses. I got it right on the interval here, but those should have been open circles in the picture. Okay. And that is it. Those are examples of all your different types of problems to prepare for.